Well, thanks for having me, and thank you to the organizers at Utah JS. This has been a great conference so far. Actually, it's the first time I'm speaking since the pandemic, so this is certainly the biggest screen my code has ever been shown on. So I'm excited for that. A little bit more about me. I go by Beseda just about everywhere, so if you want to chat on Twitter, check out some of the code on GitHub, you can do that. I've been in this game actually probably closer to 15 years now, and as was mentioned, I work at begin.com. Luckily, my talk's not about begin.com. Today, we are going to talk about an architectural pattern we've been calling functional web apps. So to get started, we're going to actually define what is a dynamic web app and why are they getting their revenge. We're going to talk a little bit of history through the three-tier architecture of, you can kind of think of the Web 2.0 days. More recent approaches like single-page applications in the Jamstack. Then we're going to talk about functional web apps. We just call it FWA for short. And then the fun part will be looking into some of the tooling. So dynamic web app, and this is strictly my definition for this talk. It's kind of a generic term, but for this purpose, we will say it's not static. So HTML is rendered on the fly, informed by a database. So it's a full stack application responsible for the entire flow of the app. It actually doesn't even have to have HTML. If your view is JSON, to me, in this definition, that is a dynamic web app. It can actually even be a single monolithic giant application, or it can be made up of many different microservices. So you might recognize some of these logos. I tried to do a little bit in order of age here. I cut my teeth actually back in the Rails days, but I would call every single one of these a dynamic web application framework. And you may not recognize the last two on there. That's because they're Rust and Go based. So there's something for everyone here. So going back in time a little bit, we'll talk about the three-tier architecture. It's essentially dividing your application, your program, into three areas. You've got the data, the application or the business logic, and the presentation. You probably know this better as model, view, controller, or MVC. Now this architecture has been around for a long time. Nothing new here, and it did bring some troubles. If you'd like to hear some war stories, talk to a Twitter engineer back from 2010 and horizontally scaling Rails in their infrastructure. But for me, the big thing was the logical architecture. So that's how I'm building my code, and how I think about it as an engineer does not match the physical infrastructure that I'm deploying to. The Linux box up in the cloud, the database, where it lives, how I connect to it is not the same as my local development. Additionally, we were traditionally pushing patches, so we weren't necessarily always redeploying the entire code base. It was Git-based deployment, but the diff was actually what was getting shipped. And one of the hard parts about this was the render was dependent on resolving the data required for that view. So if you had a slow database, an overloaded database, or really intricate queries, and that's what I think Twitter was running into with Rails as well, this led to the slow render of HTML, and your users were not happy. There are many tales about this era in web development, but it has persisted, and it's not to say it's bad. It's definitely one way of thinking about how to build a web application. So more recently, we've been in a new paradigm of building web applications, especially with JavaScript. And I've got this Jamstack-ish single-page apps. That's the best title I have right now for the category, but it boils down to what the original Jam and Jamstack was: JavaScript, APIs, and markup. They were totally static. They are totally static. This is how I still build websites. I pre-render a bunch of HTML, I upload it to a CDN, it lives there, and it's shipped to the client super fast. This means the deployment can be totally immutable, meaning I'm not going and shipping a diff, I'm not updating that deployment. I'm shipping an all-new version of my app every single time, voiding the previous one. And we outsourced the backend. So we started putting together a bunch of services for authentication, data management, et cetera. And this gave a lot of power to us as developers on the front end. I mean, it gave a lot of power to us as developers on the back end as well. And when I say outsource, I don't necessarily mean picking up Auth0 or a specific database provider. I mean we separated our front-end code from our back-end code wholly. This has some trade-offs as well. I'm sure many of you are aware, but we're beholden to the client devices. This is the huge bummer to me. I have no idea what phone I'm shipping this code to run on. I don't know how fast it is. I don't know what version of JavaScript it's running. I certainly don't know the network conditions. It's not dynamic by default. And this is something that sort of comes out of the immutable deployment. Since we're putting all of those assets up onto the cloud, the way they're shipped to our users is completely stateless. It has no idea, typically, if you're logged in. Now, this isn't an absolute statement because it has been addressed more recently with things like partial hydration and sort of bootstrapping your view on the way down. I think edge functions are really useful for this. One of the rough ones for me is the ecosystem of services, toolings, plugins, bundling, copy and paste config. How do I get all these things to work together? And my job often ends up being gluing my services together. So I don't know if anyone's built something against a Google API, but they are not going to give you notice when that thing changes, and you have to be ready for it. So this is what I want to talk about today. A new pattern, we're calling it functional web apps. We didn't necessarily invent it, but we did sort of formalize some of the verbiage around it. And when I say we, I mean myself and my colleagues at begin.com. It's an architectural pattern. And this site here, fwa.dev, you should totally visit. It's built in the same way that I'm going to be talking about today. So this is the interesting part, and I think this is the big takeaway. Before we get to code on the screen, these three things are what we consider the primary core primitives of building a functional web app. The first one, and probably the most important, is cloud functions. You might hear this as serverless or microservices, but apps are almost entirely made up of single responsibility functions. So functions that maybe they process data in the database, maybe they send an email, or maybe in the case of what I'm going to show you, they render HTML. Second, a managed database. So we don't want to manage databases. That is somebody else's job. Maybe it's someone in here's job, and I think that's fantastic. You guys are like the superheroes of my application, but I don't want to do it. So I've offloaded that responsibility of scaling, persistence, backup, all to a third-party vendor. And third, deterministic deployment. I want to declare all the infrastructure required for my application as either configuration or as code, so that every time I deploy my app, it's exactly the same, or at least exactly as I expect it to be. This is literally a screenshot from the website, so I'm not going to read it all to you guys, but you're welcome to check out these different sections on why you should be building FWAs. But my three main takeaways and what I would consider the superpowers of functional web app is that it's super powerful. It's very approachable. You can build a full stack dynamic web application in a day. Developer happiness. I personally have seen a lot of gains in my own productivity and creativity when working this way. It's just so much less copy and paste and maintenance. Third, and probably most important, is it's super accessible. I'm not asking you to learn a new language or become a PhD in the AWS console, because God knows I don't open the AWS console if I don't have to. Not to mention, it's extremely accessible for end users. Because we're working with these primitives in the cloud that are super fast and they're connected to super fast databases, we can render the view quicker, making it, in the end, more accessible for our users. So you're probably wondering, well, what are you talking about? How do I even do this? I've gone through the website. It's basically an academic white paper, and I'm going to have to learn new things. And like I was saying, you're going to have to open up the AWS console, and that's not true. Actually, we're going to walk through some cool new tools today, and they should help you out a lot, and hopefully make this whole thing a lot less intimidating. This is the part of the talk where I would normally talk about an open source framework I work on called Architect. It's actually an orchestration sort of tool chain to help you create a single application as a bunch of Lambda functions on AWS. So it's going to set it all up for you, your folder structure, and get them all deployed up in AWS without ever having to log in to AWS, except to get your API keys. So you can learn more there at arc.codes, but actually today I wanted to talk about something way more fun and way more recent that we introduced recently called Enhance. So this is probably the cutest slide, so I'm gonna just kind of pause here. This guy's name is Axel because one of the author's kids thought they looked like axolotls, which apparently everyone under the age of like 18 knows what an axolotl is. So now their name is Axel. So what is Enhance? It's actually built on top of Architect. Architect ends up being the backbone of Enhance, but you don't even need to worry about that. Just know that Architect has your back when you're trying to deploy this thing and run it locally offline in a sandbox mode. So it's HTML first with 0 JavaScript until you want it, of course. I wasn't going to come to Utah.js and say don't use JavaScript. But the real crux of it here, and the reason I'm so excited about it, is it sets you up to server-side render custom HTML elements so you can create quote-unquote real web components in the browser with native APIs. So out of the box, if you're building with Enhance, your app is going to be progressively enhanced by default and completely web native. So let's look at a sample project. So my imaginary app here is called Utah.js registration. Here's a quick npm command that I would run and a file structure that would be generated. And actually the file structure it generates is a lot shorter than this. I've gone ahead and put in a few files into different folders here, and we'll walk through each of those. Oh, I should mention everything at the top level lives in the app folder. Underneath there, you'll notice pages, which is essentially file-based routing. We've had this for a long time. People will say, that's like PHP. Yeah, and it was a really good idea back then, and it's still a really good idea now, especially if we're just serving HTML. You'll notice those files are just HTML. Index represents the root of my application, and register is /register. But the magic is that those pages are made up of custom elements that I defined on the back end. And that's what lives in this elements folder. So you'll notice here, I've got a header and a footer, both with a prefix of UTJS. And I've got a folder called register, inside there, form and badge. Those each construct a 2-word string that is hyphen separated, which that's the rule for creating a custom element. So in this case, it would be register-form and register-badge. One of the superpowers provided by Architect is that we can basically insert middleware in here. You'll notice this register.mjs in my API folder is named the same as register.html. That file is going to execute in my Lambda in my Cloud function right before register.html, and so that I can ingest, and provide data to the final view. Of course, it wouldn't be full stack if we didn't have a static assets folder. This is backed by an S3 bucket automatically. So let's dig in. HTML. Oh, it's our favorite. But it gets so much better as we start defining our custom elements. So check this out at the top. There's a lot going on here, so I've tried to highlight it as best I could. But on line 1 there, I'm using my custom element, and I'm passing in different attributes. So I've got a today attribute with today's date, and I've got a Boolean called dark mode. Below that, on line 2, is a header1 tag with a slot attribute. And that slot is targeted at something named title, and I am going to pass in Utah.js 2022. I'm going to show you the implementation for this here in a minute, or rather how I define it and use these elements. You'll also notice, hey, there's like this other chunk, this featured speaker div. We'll just call that the slotted content. So it's basically all the leftover markup that I'm passing in. The rest is just valid HTML, standard to the spec. Maybe it's what lives on our index. You can see I've created a register link, and I've got a Utah.js footer. All right, now here's the fun part. This is the Utah.js header element file in app/elements. So it's a simple pure function with a consistent method signature. So inside there, I'm going to get an HTML method and the state object. State, you can see on line 2, I'm pulling off an object called adders. Adders contains the attributes I passed in my HTML page. So I'm expecting today and dark mode. And obviously there's more logic we'd need to do here to validate they exist and things like that. But we can get into our only responsibility from this function is to return a string, specifically a string of HTML. we use this helper method. It's where all of the sort of back-end magic's going to happen, but also it gives us really nice syntax highlighting. So check this out. This is a style tag, and I know you're thinking, hey, why would you put a style tag in the middle of your page? It's not going to be in the middle of my page, but all of these styles are going to be hoisted to the top of my head, and they're going to be scoped directly to the Utah.js header element. Now here is the main markup of my element. I've picked an arbitrary element header to just act as a wrapper, but it's not required. And I've got a named slot. The named slot is called title, and named slots can have default content. This is all according to the web component spec. Enhance just is helping you hydrate it on the back end before it ever makes it to the browser. Second, there's an unnamed slot, just slot, open slot, close slot. And that's where that div tag will go. Finally, I can add additional script tags and ship arbitrary browser code. This is actually the first bit of browser JavaScript code you've seen in the slides so far. I had to name it script because if I closed a script tag in the middle of reveal.js, it would just break the whole thing. So what does this render? And I already kind of alluded to this, but you can see it's hoisted up into the head, those style tags, and it has automatically scoped them to the element, so that Utah.js header and Utah.js slotted. I sort of breezed over that, but go read up on the specifics of styling for web components. Web components, it's super powerful. And there's our script tag has also been hoisted. And here's the markup that would be output by enhance. So there's our Utah.js header, my header wrapper, and you can see I've overridden the default title. And there's that unnamed slot content with the featured speaker. Huh, I had callouts, damn it. Dang it. Let's zoom out real quick. Back to the project structure. Just as a reminder of what we've gone through so far, we've checked out the header, the footer, importantly the index file, and we've used the public folder. So next, I actually want to show the register API, the view that is connected to /register, and the two custom elements. So in our API, it's just a node file. It's just executed super fast by Lambda, and we're definitely exploring other cloud providers. We just happen to be working most with AWS at this moment. So you can see I've imported a fake database. I've set a total number of tickets, and I've even connected to my database so that my methods can have that ready to go. You'll notice the name here. It's get. So I'm exporting a named function with any HTTP verb, and this file will be invoked, specifically this method, when that HTTP method is called at that endpoint. So I'm kind of doing some more imaginary stuff where I pretend there's, hey, probably a user inside of my session, and in my fake data source, I'm looking up this user by their ID, and I'm also pulling out data.registrations all length. Now this is just totally made up. There isn't a database provider with like that. Maybe I'll make it, it's kind of neat. But the point is I'm building up all the data I need for my view. And I'm returning it just as JSON. I can write to the session if I want to, but all of this is going to remain on the server and be passed to the view as it's rendered. Here's post. This is going to handle our actual registration. I'll show you in a second how a form just posts to the same endpoint. You'll notice we don't return any data on line 25. I'm actually setting a location right back to register. Here's my register.html, super simple. We already took a look at Utah.js header and footer, and here's a new element, register form. You guys can probably follow this one, it's super simple. Line 2 here, I'm pulling off of my state object, the store, and this is the JSON that I accumulated, the thing I built in the API call. Off of that, I'm checking the already registered and remaining tickets attributes. And depending on if this person has already registered, I'm either going to show them, so in this case, they haven't registered, I'm going to go ahead and show them a form that's just a sign me up button. You'd probably want to collect credit card info as well, but for this demo, all they have to do is click this button and it posts their registration to that endpoint we were just looking at. Finally, if you are registered, it's actually going to show another custom element called register badge. Now this kind of highlights, I can use custom elements, inside custom elements, inside custom elements, all the way down. Now, aside from that one console.log, this is the first browser JavaScript. This is the definition for a register badge. For now, I've just left in a notice that folks should share their Utah.js badge, and I've linked to a script that you'll see below, and this is, according to web standards, how I register a custom element with the browser to become a full-blown web component. So this talk could go on for, I don't know, 3 or 4 hours talking about how great web components are, but this is the basic structure where I can start defining the functionality of what I want to do on the client side for every single one of these register badges that's rendered on the page. So that is basically it for Enhance. I hope it all has started to come together because I'm really excited about server-side rendering, custom elements, and web component. If you want to read more about functional web apps, it's that top URL. Enhance.dev, I hang out in the Discord most days. Arc.codes is the thing that powers it, Architect, and the company I work for is begin.com. So be looking out for an official FWA type host. I think I have a little bit of time left, so if there were 1 or 2 questions, I'd happily take them. Go ahead. Does it work with TypeScript? Yes, it does. There is no official way to work with TypeScript. So we have really no opinions on how you do it. There is an ES build step built in. So specifically for this last file I was showing you guys, you could write all of this bottom script as TypeScript, and Enhance is automatically going to bundle that and put it in your S3 bucket for you, so it's available on the front end. As far as building the API endpoints, that's just a matter of setting up your toolchain so that it targets our app structure, as of now anyway. Good question. Anybody else? All right, cool.